Friends, today we are going to see a derivation for dipole moment of semicircular ring. Okay, there is one ring here having uniform charge density lambda. Its half quarter contains a positive charge and half quarter contains a negative charge. That means from 0 to 90 degree there is a plus charge, from 90 to 180 there is a negative charge. This semicircular ring have the radius r, okay, and the charge density is linear having a symbol lambda. That means the total charge, this plus q, this minus q, total charge is 2q divided by the total length, that means pi into r. This is the lambda charge density. Okay, now what we have to do, please focus here. We have to consider a small element dx. We have to consider the small element dx from this arc, okay, at angle theta, at angle theta from the x-axis, at angle theta from the x-axis. Okay, this is the x-axis. Okay, we have to consider a small angle d, small portion or small arc dx at angle theta. Okay, now the end point of this arc, suppose this is the first point, this is the second point, having angle delta theta. Okay, delta theta. So what is the dx? What is the dx? What is the formula? How can we can calculate this portion or calculate this r? Dx is equal to r, this r into delta theta. Dx is equal to r into delta theta. Okay, this is clear. Now we can consider, this is now like a point charge. We can consider this portion is like a point charge, and we can write this dx here as a plus q. Similarly, we can do arrangement here also. We can draw a line from here at angle theta, dx here, and we can write down minus here. Okay, we can do a similar arrangement here also. That means we have converted this semicircular ring system into one point charge system, plus q minus q. Now what is the distance between these 2 point charge? So consider this radius is r, now angle is theta. Okay, now by geometry this distance is r cos theta. By geometry this distance is a r cos theta. Okay, this is the r, okay, this is the r, or you can say this is the portion r. Okay, now this is r cos theta. Similarly here cos theta. So this r cos theta becomes 2 times of r cos theta. Okay, so 2r cos theta. Okay, next the small dipole moment, because of this small portion we can write a dp bar. Okay, we can write a dp bar is equal to dq, the charge on this small portion is dq into the distance between these two small charges, 2r cos theta. Okay, now what is the dq? Dq is lambda into dx. Lambda is the linear charge density, charge upon length into length, charge upon length. Okay, total charge upon total length into our element length. What is our element length is here? Dx. What is our element length is here? Dx. This is important. Dq is a small charge on an element dx is equal to lambda into dx. What is the lambda? Total charge upon total length into this length dx. Very clear? So lambda into dx, okay, into 2r cos theta. We will replace dq by lambda dx here. So lambda into dx into 2r cos theta. Now this positive charge is from 0 degree to 90 degree. So we can integrate this system to find out the total charge from 0 to 90 degree. Okay. So we can write integration of dp bar is equal to integration of this whole thing 0 to pi by 2 lambda. Okay. We can group the things like this. R. So dx is r d theta. Dx r d theta is 2r cos theta. So we can take the constant outside the integration. We can take the constant from the out of the integration. What is constant? Lambda 2 r r. So total 2 lambda r square is the constant term here. So integration of 0 pi by 2. What will be remaining inside the integration? This cos theta d theta. Cos theta d theta. Okay. So we can write this 2 lambda r square minus sin theta 0 pi by 2. Okay. 0 pi by 2, and we can solve this accordingly. At the end we have to put here lambda 2q upon pi r. Okay. Total charge is q plus q, 2q. Total length is, this angle is 0 to pi into r. Okay. So total charge upon total length, you will get 4qr upon pi. Okay. 4qr upon pi. This is the final answer. The dipole moment on semicircular ring. Remember, 4qr on pi. What are the conditions? The charge is uniformly distributed over the ring. Okay, students. Thank you.